All right, you guys, we're going to get into Chapter 8 officially. If you're looking at the document, uh, this is all about confidence intervals. So, what is this? What's happening here? The purpose behind any survey or experiment is to know a piece of information about a particular population. Okay, that's the whole point of ever doing a survey or an experiment. So we can learn something about not just those that we surveyed or sampled, but about the entire population. Since it is often very difficult to gather that information about the entire population from every subject, a random sample is used instead. Okay, so this really just brings us back to the basic principles of statistics. What do we have next? The definitions of parameter and statistic. Okay, so we saw those way back in chapter 1. A parameter is a characteristic of a population. A statistic is a characteristic of a sample. The basic form, uh, oh, excuse me, the statistic from the sample gives an estimation of the total population. Okay, so the statistic always allows us to estimate or get a really good idea of what's happening with the parameter. At least that's the idea. But how good of an estimation? We can find what is called a confidence interval for the estimation. So we can actually know how trustworthy our statistic is, which is pretty amazing. Okay, so next we have defined the confidence interval, an interval of values that likely contains the true population parameter, and the confidence level, the percent likelihood that the confidence interval contains the population parameter value. And then I've got some typical confidence levels are 90%, 95%, or 99%. Okay, so all of this it doesn't really all click just yet. Hopefully, this drawing here will bring some of it together. In this example, this graph depicts a confidence interval with a confidence level of 95%, or you might see it written as 0.95. Okay, so what's going on there in that graph? So you see we have the bell curve, right? And at the center, and this is a key difference, at the center it's a mean, but notice it's the sample mean that we place at the center. Okay, when we studied the bell curve in chapter 6 and 7, it was always the population mean that we placed at the center. But now we're placing the sample mean at the center. And the idea is if we place the sample mean at the center of the bell curve, that can lead us to just how likely is the actual population mean, how close is it to that sample mean. So here, the whole point is, we don't know the population mean, right? So we don't have access to that information when we do a survey, let's say. So we find a sample mean, but we're really hoping that sample mean is close to the actual population mean that we're not, that would be just way too much work to calculate or to find. So we place the sample mean at the center of the bell curve, and we think of the probabilities as symmetrical around that, like extending in both directions. So here you see the 95% confidence level. So we start at the middle and we move outwards until 95% of the data falls between that lower bound and that upper bound. Okay, so in other words, there would only be 2.5% of the data on each of the ends. We actually refer to those as the tails. So the lower tail, that shaded region, would have 2.5% of the data, and the upper tail, that shaded region, would have 2.5% of the data, because there's 95% of the data at the center. This is like the middle 95%, centered around the sample mean. Okay, the critical values are the z-scores that correspond to those boundaries. So the lower bound and the upper bound, the z-scores that correspond to those, we call the critical values, because that's the turning point, right? That's the edge of our 95% confidence interval in that drawing. Okay, again, it still all probably looks pretty weird. What is this? Maybe the logic sort of makes sense, but what are we even going to try to do? Okay, usually we're trying to locate, in a typical problem, we're trying to figure out what is that lower bound and what is that upper bound. So let's take a look at practice number 1. And maybe things will start to click together. It says a researcher in the automotive industry wishes to estimate the number of days it takes a car dealer to sell a particular model. A sample of 50 of these models had a mean time on the dealer's lot of 54 days before being sold. And we will assume the population standard deviation is 6 days. Okay, so we've got all this information. They'd like to know how long it takes this particular model to sell. So they take a sample of 50 cars, and it turns out the average or the mean from that sample is 54 days before they get sold. And we know the population standard deviation is 6 days. All right, so in part A, we're going to find the 95% confidence interval of the population mean. And we'll round to 2 decimal places. Okay, how is this going to work? So I'm going to begin with that same drawing, but we're going to fill in the specifics for our example here. So we are finding the 95% confidence interval. So after I create my bell curve, and I note that the mean is 54 at the center, then I'm going to say, okay, I want to indicate the middle 95%. Any confidence interval, it's always the middle percentage. So if it's a 95% confidence interval, that means we're looking at the middle 95%. And then we're going to draw these boundaries, where that, do your best to guess about where it is. That looks about right to me. So the idea is we find this lower bound and this upper bound, and that tells us where our interval begins and where it ends, just like interval notation. Okay, great. So how are we going to figure out where these occur? First step, we're going to find the z-scores at the upper and lower bounds. Those are the critical values. Okay. Once we have the z-scores, then we're going to calculate the distance from where that occurs to the center. So you notice this formula has the z, so we need the z-score first. We can plug that in here. We know the standard deviation. We know the sample size, right? In this case was 50. So once we have that z-score, so sigma and n were just given to us, but we need to find that z-score. Once we have it, we can plug it in there and we'll know that distance. Well, once we know that distance, we're pretty much done. We can add that distance to 54 to find the upper bound. We can subtract that distance from 54 to find the lower bound, and then we know we start here, we end here, and that's our interval. Okay, well, let's go for it. How do we find the z-score for the upper and lower bounds? And you guys are going to be hopefully pretty excited. We're going to use StatCrunch to do that. We're not going to do that by hand. We could. We have the tools for it, right? We did problems like the middle percentage back in chapters 6. We saw that. We might have seen that in chapter 7 as well. Find the middle 60% or so. So we could certainly do this by hand. But at this point, we've proven ourselves, and now we can graduate, if you will, to using a StatCrunch calculator to do it for us. So at this point, you're probably not logged into your StatCrunch account. Go ahead and do that. Probably pause the video. Go log into your StatCrunch account and open up the normal calculator. So once you open StatCrunch, then you'll hover over the calculators and go select the normal calculator. Okay. What are you going to do once you have that? Oh, there's our directions. Hover over stat, then calculator, then go to normal. Okay, I forgot that step right there. Once you're in the normal calculator, use the between feature. So at the very top, there's the standard or the between. Use the between, right? Because we're talking about the middle 95%. And you're going to see a little something like this. They're going to give you a graph of a bell curve as well, of course. We're going to say the probability that blank is less than or equal to x is less than or equal to blank equals, and this will be blank as well, but here's what you're going to do. You're going to type 0.95 into that answer, and we're going to use the StatCrunch calculator backwards because we know the middle 95%. We're trying to figure out these here. Now the StatCrunch calculator, there's some things that I wish were a little bit different. The truth is, this should be a Z. We're finding the Z scores first, not the X. So that's a little misleading, but just know that it should be a Z. Also, they have or equals, which is not technically correct. They should just be two less than signs, since you cannot equal anything in a continuous distribution. Okay, anyway, that's just my hangups with this. But otherwise, it works really well, right? Okay, so once you type in 0.95 and hit enter, it will then populate those two spaces. Hit compute, and you should get these values right here. Negative 1.96 and positive 1.96. And hopefully we're not surprised when we find it's the same value, one negative, one positive, because it's symmetrical about the mean at the center. And so that is the z-score for the lower bound, and that is the z-score for the upper bound. These are the critical values. Okay, once we have those z-scores, then we go to step 2. We're going to calculate the distance using z times sigma over the square root of n. Let's see how that works. Try and keep this on the screen if I have space. Okay. Here we go. So notice we're only going to use the positive z-score. So this is, makes our work go a little bit faster. We don't need the negative one because they're symmetrical. We can just take the positive z-score and plug it into our formula. That's always the case with confidence intervals. Okay, so maybe you hear that noise in the background, some folks driving by my house. Oh, wow. Okay, so we'll take that z-score, plug it in here. We know our sigma and our n as well. Okay. So we'll take 1.96 times 6 over the square root of our sample size is 50. And we'll get that right there. I rounded to 2 decimal places because that's what the problem indicated for us to do. So we'll go ahead and do that at this point. 1.66. This is the distance from our sample mean to our upper bound and to our lower bound. And so we're almost, and I've got a drawing to help us out with what we just found. 54 is at the middle. So to get to this upper one, that's a distance of 1.66. To get to the lower one, that's a distance of 1.66. All we got to do is figure out what these numbers are and write it like an interval. And we have the answer here. So the upper bound, well, we're going to take our 54 and we're going to add 1.66. It's going to give us 55.66. Our lower bound, we're going to take 54 and subtract the same number and get 52.34. And so we can answer the question here. Our 95% confidence interval is 52.34, comma 55.66. 95% of the data falls between these two values, the middle 95%. And there you go. That's our answer for part A. At this point, I'd like to, just write one statement like an interpretation. What did we really do? What do we really mean when we say 95% confidence? And this will hopefully tie it all together. The 95% confidence interval tells us we are 95% confident that the actual population mean is somewhere between 52.34 days and 55.66 days. So if you think back to the problem, right, they took a sample of 50 cars. That's quite a lot. And they found the mean for those 50 models, right, how long it took them to sell. The mean was 54 days. So, someone could stop there and say, hey, we sampled 50 cars and the average was 54 days. I think 54 is a pretty good guess at the population average if you looked at every car, every one of these models sold. But we can go a little bit further and we can say, okay, we're pretty sure 54 days exactly is not the average for the actual population if we looked at every one of these cars, right? It's the average for our sample, but it's not the average for every car of this model that's out there. But it's probably the average of all those cars is probably pretty close to 54. And so we do our calculations here and we do our statistics and we can come back and say, you know what, it's probably not 54 exactly, but we're 95% sure that it's somewhere between these two. So it might be a little bit less than 54, it might be a little bit more than 54. We're 95% sure it's between 52.34 and 55.66. Is there a chance that the actual population average is either above this number or below this number? Yeah, there's a chance that actually the population average is above here or below here. But only 5% chance based on what we've done. And so, if we're 95% sure it falls in there, then that's pretty confident. That's pretty confident. Okay, let's do this again. In part B, we're going to do a 99% confidence interval. So let's see what will change. Okay, so if you're 99% confident, how does that affect the numbers for the lower bound and the upper bound? Okay, so this time we're going to draw that bell curve. We're still putting our sample mean there at the center. And we're going to draw a couple lines here, there and there, and shade the 99% confidence interval. Let's think about this for a moment. If we're going to be 99% confident, what is that compared to 95% confident? Well, think for a second, right? 95% confident, those lines would have been a little bit closer to the middle, right? So maybe like these lines here that's 95, and where we've drawn, that's 99. So when we make it 99% confident, these get pushed a little bit further out because now we're capturing 99% of the data, where maybe these lines only captured 95%. Okay, I'll get rid of that. So it got a little bit wider. Okay, let's see how this plays out then. We're going to go about it, exactly the same way. It's just the numbers that are going to change. So at this point, we're going to go to StatCrunch into the normal calculator. We're going to use the between. Be sure you're using the between, and it looks something like this. Probability blank less than x less than blank is equal to, and there we type in our confidence level, all right, 0.99 in this case. and we let the calculator work backwards. So we hit compute, and we should get these two numbers right there, negative 2.5758 and positive 2.5758. So those are the critical values. Those are the z-scores for the lower bound and the upper bound. If you remember, we only need the positive one because we know one's positive, one's negative. That's just the way it's always going to work here. So we'll find the distance between our mean and those boundaries. So we take our positive version of that z-score, multiply it by standard deviation over the square root of n. So in that case, it's 6 over square root 50. And we're going to round that to 2 decimal places because that's what the answer is going to do very shortly. So we know the distance from the center to both edges, both boundaries, is now 2.19. Notice, if you compare to part A, that distance got a little bit longer, right? Before it was 1.66. So we have to go out a little bit further in order to capture a higher percentage. Okay, in any case, what are we going to do with that? We're going to take 2.19, we're going to add it to 54 to get the upper bound. We're going to subtract it from 54 to get the lower bound. So let's walk through that. I'll just show you these. Okay, so the upper bound, we add the 2.19, 56.19. The lower bound, we subtract 51.81. And there we have it. That's our confidence interval. The 99% confidence interval this time. It's from 51.18 to 56.19. And once you get good at these, the steps are pretty quick. It's, really nice that we're using StatCrunch to do the dirty work. Now let's compare, or let's think about what does this answer mean, and then let's compare it to what we did in part A. So this answer means, okay, so we did our sample of 50 cars. We got an average of 54. So if we're thinking, so what does that mean for the population mean? Well, it's probably not 54 itself again, but we can say with 99% confidence that the actual population mean is somewhere between 51.81 and 56.19. A little bit below 54, a little bit above 54. We went 2.19 in both directions. Okay, so if you think about how this compares to part A, I've written out, this was our answer to part A. This was the 95% confidence. And here's what we just found with the 99% confidence. What happened to the lower bound and the upper bound when we got more confident? When we're 95% confident, those are our values. When we're now 99% confident, these are our values. Well, what happened? And you look and you're like, well, the lower bound got lower and the upper bound got higher, right? So when you become more confident, then you have to allow for more error, right? So greater confidence comes with widening your confidence interval. So we're not only 95% confidence between these, but we're 99% confident. If we widen it just a little bit, we're even more confident. And of course, it would also work backwards. If we were to get less confident, it's not uncommon to do a 90% confidence interval. Then, we'd have to go through obviously all the steps, but then this number here would get a little bit bigger and this number would get a little bit smaller, right? Because we would pull it closer to the middle. If we have less confidence, then it tightens up. Okay, I'm going to stop this video here. More to come.